So what we have here is my process in becoming a front-end developer, and thank you to Oliver for setting me up if you saw his talk. But first I want to talk about why I did this, because it needs a little motivation. So I wrote what was effectively a graph plotting module. We can simplify it to that, but it didn't just plot a graph, it plotted graphs and animated them. This is how you animate a slide. So it does a lot, and so I wanted it to be fast, right? CPU time was going to be a problem, so I needed to be careful with my choice of programming language. But I wanted everyone to be able to run it, right? So obviously, I'm lazy. I didn't want to set up a build that did multi-platform targeting and everything, so I only had one option. No, obviously not. So compile it for a browser and run it in the browser. Yeah, that's what I'm going to do. So what did I do? Or more accurately, what have I done? So I wrote C++ code that uses OpenGL, and then Emscripten, the compiler toolchain, translates OpenGL to WebGL, which is JavaScript code. Then Emscripten compiles the rest of the C++ into WebAssembly, WASM, and then that stuff is run in your browser, okay? Which means that inside of my slide deck, in my browser, is OpenGL code running right now, which is a really bizarre toolchain. And all of this is actually increasingly common. This isn't the weird part. WASM is actually really, really cool. The problem appears when you actually want to test this kind of mess of code, right? So what do you do? Since I'm apparently a front-end developer, I wrote a web page. So this is a web page that ran unit tests inside of my browser. And not only, well, not unit tests, end-to-end tests. And not only did it run them, but it also has a render canvas inside there and, you know, nice syntax highlighting. So I have some hacky JavaScript to intercept output streams and reinterpret all the colors. Yeah, this isn't useful for unit tests at all. But this is incredibly useful for an end-to-end test. Like if you need to test an entire render pipeline on a new platform, like a browser, which you haven't tried it on. So this is really great. So I use this for GSL shader tests, where like my shader, if I compile it into native C++ and then run it with OpenGL natively, that could behave differently. There are different features, so I needed to test it on the platform. So how does it work? Just very quickly. I think it's the perfect balance that we look for in a new project, which is clean and hacky. So yeah, I have JavaScript slides. I hope you're all okay with that. But yeah, you pass it some tests. You could also just query the disk if you want to run it natively, but we just give it some module names for test modules. And then it goes over all of them. It can do them asynchronously and lock the I/O safely, but just for slides, it's better to do it synchronously so that you can guarantee the order. And then we load a suite and we run it and then call whatever callback we were given and make sure to catch any exceptions that we have. And then, yeah, this is some WebAssembly glue. We import the file and default it and then call an onloaded. So that this is the actual main call where we're calling our main function here, which is kind of nice. And then we just run them all. So these are the actual tests. Like this is the suite that failed. I wrote them in Boost UT. It uses C++ 20, and it's running inside of a console inside of my browser. And it's running an entire renderer that just like renders to an HTML canvas, which is just the greatest mashup of weird tools that I've ever encountered. So yeah, that's all I have. Thank you.